Hi everyone, welcome to this video on lesson 12 of the Earth and Climate scheme of work on atmospheric pollutants. There's a few things to say about this lesson before we go into the exposition. So one is, as I've kept saying in this sequence of lessons in the second half of the scheme of work, it all comes back to the carbon cycle. And remember, what we're doing in this scheme is using each lesson to build this bigger picture. Because what we want students to remember is the bigger picture, the kind of macro, and then it will be easier for them to remember the details, the kind of micro, if they've got it organised in their minds like this. So in the previous lesson, we looked at the combustion of carbon dioxide and how that releases, combustion of fossil fuels and how that releases carbon dioxide and water vapour into the atmosphere. And then we've got this lesson on atmospheric pollutants. Now, the reason I'm doing it here is because it kind of follows on with the story, and we can kind of look at some of the other things that are released by cars when we burn fossil fuels. This is actually a lesson taken pretty much from the GCSE spec. I think it's fine to put it in here because it's not too abstract. It comes from the atmospheric chemistry unit though. So in a sense, it's a bit strange that we haven't talked about the atmosphere yet, which we'll do in a later lesson. But we have talked about, we are now going to talk about atmospheric pollutants. But I do think it fits quite nicely because it builds from that lesson on burning fossil fuels, especially in engines. But again, so that's the rationale for it there. So yeah, there's quite a bit that students have to recognise. And again, it's going to be quite hard for them to remember. And it feels, if you just look at what's in the spec, it feels kind of abstract. So I think a helpful context here to make it a bit more concrete and I suppose relevant and meaningful to students is to talk about ULEZ, which is this policy that's been adopted in London, which essentially, I mean, in very, very simple terms, it discourages drivers from driving diesel engines. So what I've done here is drawn two vehicles, so a small car and a big lorry. And what we want to do first is emphasise to students that this is a petrol or gasoline engine. I'm just going to put petrol for now. But you might put, yeah, we can put gasoline as well, because that links back to what we did in the fractional distillation lesson. So we've got a petrol engine here and a diesel engine here, a big chunky diesel engine with lots of torque to get that lorry moving with all its load. And what we want to do is just compare what's going on with petrol and diesel engines to give students a sense of why Sadiq Khan and others who support ULEZ are trying to get diesel engines off the roads in London. So what we can do is show, well, okay, with a petrol engine, well, what we're doing is putting yeah, I'm going to draw it here. We're putting gasoline plus oxygen. I'll just put O2 in. And then what's happening inside the engine, and this is just building on what we did last time. If I zoom in on what's happening inside the engine here, is that, again, I'm just going to, rather than going down the road of talking about octane and C8H18, I'm just going to do a really simple one. Last time I just did it as O, this time I might do it as O2 actually. It doesn't really matter, we're just kind of illustrating the point at this stage. But these two combine, and therefore what happens is we end up with these two molecules. I mean, they're not actually bigger, but again, this is very much schematic here. CO2 and H2O. So we say, okay, where do we put the gasoline in? Well, that's when you fill up at the petrol station. Oxygen just comes from the air, so that rushes into the engine and that supplies the engine with the air. And then we've got the exhaust pipe at the back here. So what's coming out of the exhaust pipe? Well, we've got CO2 and H2O out. Now, one atmospheric pollutant we can talk about straight away, even with a petrol engine, is carbon monoxide. And we can say that actually sometimes what happens is if this process doesn't happen properly, then we might not, especially if there's not enough oxygen, then we might end up with something else coming out, which is carbon monoxide. And I'm going to do this in red just to show that it's something a bit different. That's not what we want. So we might add here, one atmospheric pollutant is carbon monoxide. And again, you might wish to label this to students because they'll be familiar with CO2. They won't be familiar with carbon monoxide. And obviously you can direct their attention to the fact that it's mono, so there's only one, compared to dio where there's two oxygens. And you can talk about some of the problems of carbon monoxide, essentially breathing problems and the fact that it can aggravate asthma and things like that. So that's an issue that can happen in either case. But by and large, the reason behind the ULEZ policy is that, I mean, it's not great to drive cars because you're pumping CO2 out, and as we're going to find out later in the scheme of work, that contributes to the greenhouse effects, which is a big issue, as well as the water vapour. But actually, in terms of these atmospheric pollutants, gasoline engines aren't as polluting as the big diesels. So we're going to look at why that is now. So let's look here. Now, in this case, again, so we're putting the fuel, in this case diesel, plus O2 in. So again, when a lorry is filling up at the HGV section of a big petrol station, again, students will be quite familiar with this. They're putting diesel in and then getting oxygen in from the air as it rushes in. And then something's going on inside the engine. So again, let's zoom in on what's going on here. But what we want to illustrate here is that it's a bit different. So what should happen is pretty much the same as before. So what should happen is this, that the fuel, which I've just labelled as a black molecule, combines with oxygen, and we end up with carbon dioxide molecules and H2O molecules. So this is all that should happen. But what actually happens is that, well, firstly, you do also get some incomplete combustion if there's not enough oxygen. So you do still get some carbon monoxide. So I'll put that as CO. So there's some carbon monoxide coming out. But you can also get an issue where, because, and this is one thing that you're just going to have to tell students, but diesel engines run hotter. I haven't looked at why that is. I'm just going to assume that they run hotter, and perhaps I should have drawn this actually, because as we saw in that fractional distillation lesson, diesel molecules are larger. So it's a more viscous liquid, it's larger molecules. So because it runs hotter, you also get the fuel, or what happens is some nitrogen from the air, and again it's a bit complicated, but essentially because it's hot the nitrogen splits. Some of that nitrogen reacts with oxygen as well. It's hot enough for nitrogen to react with oxygen. So you also get these oxides of nitrogen forming. So we get a bit of NO and a bit of NO2. So I'll do those, in fact I'll do those in green. So I'll do NO, NO2 forming. So these are oxides of nitrogen. And we want to stress to students that oxides of nitrogen, these are not great. They can be acidic, so they can cause acid rain, and they can also really aggravate asthma and cause some breathing problems as well. So that's an issue that we have there too. The last thing that can happen if there's not enough oxygen available is that you get some kind of a bit of a breakdown of the diesel molecules, but not a complete breakdown. So if there's not enough oxygen, you also get what we call particulates forming. So these are kind of big chunky molecules that haven't properly been broken down. So I'm going to do those like this just to illustrate that's what's going on. And again, these can get kind of embedded in the respiratory system. They can cause all sorts of breathing problems, especially for those people with asthma. And it's worth giving students some case studies about some really sad stories about how children who've had asthma, who've lived close to a main road where there's lots of kind of trucks and heavy traffic and heavy machinery, have actually really suffered, and a couple have even died because of this pollution that's been getting into the lungs and stopping them from being able to breathe. And then, so this is the very abstract picture. but we can come out and say, well, look, so what's happening here, the reason that ULEZ happened is that if we look at the exhaust wouldn't be there, would it? But we can just draw it there for the time being, just to, or maybe it would be up here, like one of those American road movies. I'll just draw it here for now. It doesn't really matter too much. But what's coming out of the back of a lorry is very different to what's coming out of the back of a petrol car. So we're getting much more stuff out. We are getting the CO2 and the H2O out, but we're also getting the carbon monoxide. Again, we're also getting the oxides of nitrogen, NO plus NO2, and we're also getting the particulates, which I'll write here like this, which can cause those problems that we've been talking about. So that's one really nice context and something very concrete that you can show to students just to illustrate that point about some of the different things that are coming out, especially from diesel engines. Now the last one to talk about, which I've not drawn here, is to do with coal. So when you burn coal, coal often contains impurities, mainly sulfur. And again, you could draw a similar picture to say, a bit like the nitrogen reacted with the oxygen here to form these oxides of nitrogen. Well, the sulfur in coal reacts with the oxygen and you get sulfur dioxide, and that again causes acid rain as well as aggravating breathing problems. So I've not drawn that here, but you could draw a diagram to illustrate that and say this is why coal power stations are particularly polluting, and coal fires and things as well. You also get issues with coal of the particulates as well. So yeah, it might be worth talking, especially if you're in a London school, about open fires and wood burners and things like that. Why as a society we're moving away from those as well, especially in urban areas. So there's loads of contexts that you can give to introduce this, in order that what we want students to take away is are these main particulates, where they come from, what kind of dangers they can cause. So I hope that is clear, and in the next lesson we'll be moving on to generating electricity.